So MIOX is the leader of on-site, on-demand chemistry. We also have been working in the oil and gas industry for many years with some of the biggest names in the industry. What we found is oxidants eliminate the most bacteria, period. They do it fast and they do it effective. We can do high treatment rates so we can recycle the most water per day. We eliminate the H2S. We can reduce the iron, which can cause scale, and we can reduce the chemicals on the road. So most importantly, we're a safer process and we're lower cost to put more money back into your budgets. So one of the first things that MIOX wanted to do was actually test if mixed oxidant had applications in the oil and gas market. So what we did is that we actually built a field-size pilot unit to treat produced waters in pits around various plays in the U.S., so different shale plays we went to, and actually treated the flowback and produced water on site. This slide is indicative of some of the early tests we did. We actually took some samples. The samples were growing 11 million bacteria per milliliter of fluid, and we would treat it with mixed oxidant at 50 ppm. So if you see that little white dot right at the end of the blue arrow there, that's equivalent to 45 bacteria per milliliter of fluid. The big black circle is actually, every pixel is 11 million bacteria. So 11 million pixels to represent 11 million bacteria. That large kill is indicative of oxidant type technology. So mixed oxidant can actually get that type of kill, whereas your conventional biocides can't achieve this level of kill and this quickly. So what is mixed oxidant actually? So mixed oxidant is actually where we take a salt solution, so we take brine, regular sodium chloride, we electrolyze it through a titanium anode and a titanium cathode, and we create what's called mixed oxidant solution. So we actually liberate sodium hypochlorite and hydrogen peroxide from this solution to treat the produced waters. So we batch dose mixed oxidant into the produced waters to achieve these kind of kills. Now, the reason we know we have additional oxidant species, such as hydrogen peroxide, by the process of elimination, and we can also run studies based off of actually killing very hard to kill spores. So Bacillus globigii is pictured in these slides here, and it was dosed with both sodium hypochlorite and mixed oxidant. As you can see, the mixed oxidant on the bottom has a much higher level of kill. So this brought it all the way down to 16 CFUs per milliliter, whereas the hypochlorite didn't have that effective of a kill. Now, what does this mean? This means to the oil and gas industry, Bacillus globigii is much harder to kill than SRBs, APBs, and things like that. So we get a much better kill and much faster, and we definitely have something more than sodium hypochlorite. This test was actually validated in third-party studies by the Center of Disease Control. MIOX is the leader of on-demand disinfection. We've been in business for over 18 years. We expect to be here at least in 18 more, so we're going to be here when you need us. We have scalable technologies, we have multiple chemistries, and we address many, many markets, such as municipal water, food and beverage, industrial and cooling, agriculture, semiconductor, and of course, oil and gas. We have 48 patents pending or issued to date. We have multiple technologies that are scalable. We have technology from the size of a water softener all the way up to 3,000 plus pounds per day, which is about the size of 2 refrigerator units. And you can see the scale there next to the guy there. And these are really small footprint units, and it can really, really treat a lot of water, whether it's drinking water or produced water or brackish water. We can treat out the irons, we can treat out the H2S, and we can treat out the bacteria. We have multiple chemistries, which other companies don't have. So we can do mixed oxidant, we can do regular sodium hypochlorite, we can do an advanced oxidation process, and we can also do an EQUAT, which what I like to consider that as a dual biocide. So for an oil and gas application, this is where you actually get that large kill with oxidants, but we can also put a conventional biocide in there that won't interfere with the oxidants and leave that water sterile longer. The first very large-scale mobile product to come off the product line was the Blackwater unit. The Blackwater unit was designed to treat produced water, flowback water on the fly or on site as you needed it. So some of the things about the Blackwater unit, again, we treat produced flowback water recycling. It could be set at a saltwater disposal well for maintenance treatments or even biocide kill on the surface. We also could do frac water on the fly treatments with this. We could also do enhanced oil recovery water treatments to be injected downhole or used on surface for odor control and things like that. It generates 800 pounds of mixed oxidant per day, and I'm going to go into a little bit about what does that mean. It generates at 4,500 milligrams per liter solution to dose with. It needs a 480 volt, 3-phase, 250 amp service, and it requires 3 pounds of salt per pound of free available chlorine and 3.5 kilowatt hours per pound of free available chlorine. So to rig up the Blackwater unit is very, very simple. So essentially you run your electrical connections. This can be a diesel generator on site if needed be. You hook up your makeup water, and then you hook up your dosing line. Then you would obviously put some salt into the system, so you can do this either via sack salt, or in this picture we have the dotted line, which is an optional brine line. So you could actually truck in 10 pound per gallon brine, fill up the tank, or put a big standalone tank on the side of this, and you need very, very little interaction with the MIOX unit once it's up and running. Then you would run your dosing lines into whatever water you want to dose, and the system from there is programmed how do you want it to manage the water or treat the water. This could be done manually, or this could be done automatically via sensors. And that's all done with our Allen Bradley controllers on board in the unit. So let's talk about the global water supply a little bit. I got this from the USGS website, and they took all the water from the globe and actually put it in a sphere above the US. And this shows the global water supply. Now, the little dot you see here is the actual fresh water supply. So we do have a finite amount of fresh water that we can use for various things, whether it's agriculture or oil and gas or watering golf courses. Well, the one thing about the oil and gas is sometimes we actually do what's called a once-through scenario. So you actually have the water, you acquire the water, pay for it, fresh water sources, surface sources, things like that. We transport it to site. We probably treat that water with a biocide. We then pump it down the hole, and then what you see is it comes back up, and then it's as produced or flowback water. It's transported typically to a saltwater disposal well. Again, it's treated for biocide there, and then we dispose of it, and it costs to dispose of it. Now, this water is a once-through scenario, so it takes fresh water, injects it down hole, that water comes back up, it's no longer fresh water, so we dispose of it. So that water is gone, it's consumed, it's taken out of that fresh water droplet you saw, it's taken out of that life cycle and won't return. Now, what I'd prefer to see is a recycle scenario. So you actually take the water the produced water that was being transported to the saltwater disposal well, take it from there and transport it back to site and reuse that water. Now, what does that do? That takes out your acquisition of water costs. It takes out one of the transportation costs. It also takes out the biocides that you'd use either on frac location and the backside location if you use MIOX on location for this recycling, and then it gets rid of your disposal costs. So if you add all those costs up, you have almost $2 to recycle a barrel of water, and that's where you fit in a MIOX treatment or a filtration treatment, and it's much less than $2 per barrel to do that type of treatment, and gives you an economic return on recycling water for your frac operations. So let's compare MIOX to chlorine dioxide. Chlorine dioxide has a very volatile feedstock cost price, especially hydrochloric acid. It can go up, it can go down. But typically, if you were talking a drum of MIOX versus a drum of chlorine dioxide just for feedstocks, we're going to be able to provide a MIOX service much cheaper because we're 1/8 or 1/10 the feedstock cost of what chlorine dioxide is. Now, what is a typical dosage? So the Blackwater unit can actually dose a lot of water very rapidly. So if we're talking a fresh water or light demand produced water, so let's say 20 ppm dosage, we can do 100,000 barrels a day with the Blackwater unit. If you start getting into some fresh and produced waters, we've seen 20 to 75 ppm ranges. That means we can dose in that 28 to 100,000 barrel range. 75 to 100 is usually a real high demand scenarios, and that one we can do 20 to 28,000 barrels. And then in your extreme demand scenarios, depending on ones, we can still even do 5,000 barrels a day. So this is a very inexpensive way to treat a lot of water rapidly. So here's some field data from one of the Blackwater units that we have, and this shows some of the water samples that were collected from treated and untreated water. So in this scenario, we had 2 pits. One was treated, one was not treated, and the trucks kept offloading half to each pit. So as you can see here, we got a very, very good bacterial kill. They had 10 million bacteria plus of SRBs per milliliter, and we literally got this down to less than 1 bacteria per milliliter. So This is a very, very good kill scenario. We see this over and over again, and this is what oxidants can do in the oil and gas industry. Some of the other things on the right to notice is we normally also help treat out some of the manganese and the iron, and this particular water sample didn't have very high levels, but you would see those levels drop in actual field samples if you had those levels in your water. And also, we don't affect the pH very much on this water. So just so you know, we affected 3 or 4 points generally, depending on how much you have to treat the water and what the demand of the water was. One of the beauties of the MIOX technology is it's very, very safe and effective. So when you're talking about health and safety rating, our NFPA for shipping, our label rating there is 100. This is the same cleanup as if you spilled water on location. This is generally even safer than the produced water on location, so you don't have any nasty chemicals to worry about your employees. This is a very low manpower unit. You can stick your hand in the oxidant without burning yourself. All you have to do is wash it off. So the levels of chemicals needed for this is just salt, water, electricity, and then you have an oxidant solution that's safe. Unlike some of the other things that you have on site, whether it's bleach or HCl or chlorine dioxide or ozone, those things don't have the same safety profile that we have. So just an overview here is oxidants eliminate the most bacteria, period. We kill it rapidly, we kill it fast, and we kill it almost completely. We have high treatment rates, so we can recycle more water faster and more economically. We eliminate the H2S. We reduce the iron, which can cause scale. We reduce the chemicals on the road. You're predominantly shipping lots of water, lots of chemicals on the road. We can generate this on site, so it's not on the road. It's a safer process, and it's lower cost to you. So my name is Charles Mowry. I've been in the oil and gas industry my entire career. I'm the Director of Business Development for Oil and Gas and MIOX Corporation. If you have any questions, please contact me. My email address is charles.mowry@miox.com, or visit us on our website, miox.com. Thank you.